Today we discuss about nature and properties of nuclear radiations. In this section, we also add MCQ link in description. This section then delves into the specifics of alpha particles. An alpha particle is identical to the nucleus of a helium atom, consisting of 2 protons and 2 neutrons. Alpha emission mainly occurs in heavier elements, making the daughter nucleus have an atomic number reduced by 2 and a mass number reduced by 4, compared to the parent nucleus. Gamma emission might follow alpha decay. Importantly, all alpha particles emitted from a particular decay scheme have the same energy. Alpha particles have a mass about 4 times that of the hydrogen nucleus and carry a positive charge, which is twice the positive charge of an electron. When alpha particles pass through matter, they cause ionization, which is the process of removing electrons from the atoms present in the matter. Due to their relatively large mass and charge, alpha particles are less penetrating and can be stopped by even a thin sheet of paper. Now let's move on to beta particles, which include negative beta particles and positive beta particles, also known as positrons. These are electrons with negative and positive charge, respectively. Beta particles are created and ejected from the nucleus during radioactive transformations. Positron emission is not as common as negative beta emission. The daughter product from positron disintegration has the same mass number, but a different atomic number, with 1 less proton in the nucleus of the parent element. Beta particles are electrons, either negative or positive, and they have a range of a few meters in air depending upon their energy. Like alpha particles, they ionize matter, but the ionization is less intense. Beta particle penetration is comparatively easily absorbed in matter, and their penetration power depends mainly on their energy and on the atomic number of the absorbing material. Next, we have electron capture, which is an alternative process to positron emission. In this mode of decay, the proton in the nucleus captures an electron from an inner orbit, usually the K shell. This process transforms the proton into a neutron, and a neutrino is emitted. The atomic number of the daughter nucleus decreases by 1, while the mass number remains the same. It will always have 1 less positive charge than the parent atom. An electron from an outer orbit will subsequently fall into the inner orbit, emitting characteristic X-rays of the daughter atom. Finally, let's discuss gamma rays. The emission of an alpha or beta particle is generally accompanied by the emission of gamma rays almost instantaneously. After alpha or beta decay, the daughter nucleus is often in an excited state, and the excess energy is released in the form of electromagnetic radiation called gamma rays. Gamma rays are electromagnetic radiations, similar to X-rays and visible light. They are highly penetrating. The higher the energy, the higher the penetrating power. They do not possess any charge and do not ionize matter indirectly.